Good morning, good evening, good afternoon, wherever you are. My name is Vishnu Dutt, and we are into the session number 55 of OSPF, BGP, and MPLS session, right? So, from today, we are starting the design aspects of whatever we have learned, right? And believe me, if you have a strong fundamentals, then you can actually design the network with the help of some more readings, right? So let's introduce our old character, which were with us uh, when we were learning the routing fundamentals, when we were learning the OSPF, and those two characters were Mr. Rahul and Anjali, right? And these two characters, Rahul and Anjali, both were with us in all the 54 classes, right? And what happened? That in the meantime means 1 year or 2 months, 2 months back, Mr. Rahul applied for a job. He has only 4 or 5 years of experience in this IT field, and he had applied for a new job, and now he got a job in which he required to design some of the networks, right? So the job role is design engineer, right? Network design engineer, or maybe an architect, but he is having just 4 or 5 years of experience, and that is why Anjali is talking. Uh, they both are talking, and Anjali has some concern that Mr. Rahul, that you have only 4 years of experience, and now you are a design engineer. Now, how you are going to do the task at your work? Then Mr. Rahul is saying that according to Vishnu, if you have a strong fundamentals, then you can definitely go and design, right? And that is what we are going to see in this session, that it really depends on your fundamental knowledge. If you have that fundamental knowledge, then you can basically design the network, and whatever is required to uh, to design a network is basically your fundamentals plus some more readings, right? And this is what we are going to see in this session. And the agenda of this session is that we are going to uh, learn how an enterprise internet edge is going to be designed by using BGP, right? Although there are so many aspects to it, there is a security aspect which is very, very important, but that we are going to take out. We are not going into the security of internet edge, but we are learning that how can we design an internet edge using BGP, right? And to understand where that what that edge is, definitely I will give you a brief introduction about the enterprise today. Okay. So as I was mentioned that you should have the fundamental knowledge, but you should have some more things, some more reading also, right? And believe me, as I mentioned, that if you have gone through those 54 uh, classes, whatever we have before this one, then whatever you are being going to read more depending on your project, it is going to be very, very easy, right? Suppose you are going to find you want to find an article where which is the demand of your project, which you haven't which you haven't came across in last 54 session. Then if you just Google it, if you try to read it, believe me, now reading that article is going to be piece of cake for you because you understand the fundamentals well, right? So Mr. Rahul, as we are going to see, is going to be assigned a first task into its new job, which is to design an enterprise internet edge. And he's considering on these two factors also along with the fundamental knowledge. And believe me, somewhere during the fundamental classes, we have explained all these things, right? Then we are going to talk about what is the customer existing design today, right? And what are the customer requirements? If time permits, which is not going to be, it is good that we are going to start the brainstorming on requirements, And probably this we will be doing tomorrow from my Hindi class experience. And then probably we will be presenting the design to customer. So this is going to be the agenda. Agenda is pretty simple today. We have introduced our old character again. Mr. Rahul is in its new job, which is a design engineer, and he is going to get his first project to design an internet edge of the company, right? But before going into that, let's understand some nitty-gritties of enterprise network, right? If you if you were part of my SD-WAN class, then you should have seen this diagram, right? आपने देखा ही होगा इसको. And then basically what we are going to talk about here is that how a typical enterprise network look, right? So what is the definition of enterprise, right? Enterprise is actually composed of maybe a campus, then multiple branches which are far away from each other. Maybe this branch is in Hyderabad, this branch is in maybe Rajasthan, and this branch is in maybe somewhere else, right? Maybe Chennai. This is my main campus, suppose that is in Delhi, right? And you all know that because all of these guys want to have access to the application of the company, and that is why all those applications are running inside the data center. Everybody needs connectivity, connectivity between the campus and the data center, and maybe the data center is in Mumbai. If that is the case, you all know that the distance between Delhi and Mumbai is approximately 1000 to 1100 kilometers, and we are talking about here WAN, wide area networking. So using wide area networking, you can connect all the campuses, branches, and data center. And we have talked about one technology, which is MPLS, and you can see that most of the branches are connected and the data center is connected over this MPLS, right? If I say connected, then it means that the campus can talk to data center over MPLS. And I'm talking about MPLS L3 VPN, which we have learned in last 14, 15 classes, right? Then you must be thinking this, what internet is doing here? This internet actually providing the connectivity between the data center and the branches, because internet is everywhere, but this internet is not used to access the google.com, the youtube.com, and something else, right? This internet is only for the connectivity between the branches and campus. Then you must be wondering that, Mr. Vishnu, internet is internet. If I can go, if I have a connectivity from here, then basically I can go out and reach to various servers on the internet. It is as simple as that. These servers are maybe the google.com or the youtube.com. But I wanted to make sure here that actually this yellow cloud, which is the MPLS cloud, and the internet cloud, which you are seeing here, this is just for the connectivity between the campuses, data center, and the branch, right? And why I cannot go directly to the resources on internet like YouTube, Google, or Facebook? The reason is straightforward, right? This is my enterprise network. I am coming out from the company, right, or the campus or the data center, and I want security over this link, right? If I can go out over the internet, anybody can come in my campus too, right? And there are so many branches campus, I cannot put firewall everywhere. And that is where most of the time I have that firewall configured into the centralized place. And that centralized place is known as your data center. This data center is running actually some of the applications, right, which are very, very important to your company and maybe your company website also, right? What is the meaning of company website? Suppose this is the network of Sports India, right? A company, a fictitious company, which we have been, which we were which we talked about in SD-WAN classes also. So this is a company which is online company, and maybe people on the internet can actually uh, give orders from their laptop, from their mobile phone, and so on. So this website must be running somewhere, and this website is running on this server in the data center, right? And to save this company from the internet user, we have this firewall configured. And that is why the data center contains the firewall, because it is hosting some of the servers which are very, very important for the company, the crucial for the company. If these servers gets hit, then basically company lose the business. And that is why we are having this firewall. Because at the end of the day, we are connecting various servers. We are going to need these switches, routers. And if the traffic on these servers is increasing, maybe you are running this website over 2 or more servers, and you need something called balancing of the load between these servers. And that is why we are having this load balancer. A typical data center looks like this. A typical enterprise looks like this, right? And now I have an internet here, right? So basically, if a user, maybe sitting in the campus, user number A or user number B, wants to access youtube.com over the internet, maybe, which is running somewhere here over the server, right? Maybe the youtube.com is running here, and you are actually, your one of the employee number A wants to interact with this YouTube, then company policy says that because I have firewall and only in the data center, so basically you should come over the data center first and then pass through this firewall. We have the firewall policy for you. And if the firewall policy allows you, then you can go out and access the YouTube on the internet, right? Then you must be thinking why there are the policies on the firewall. This is straightforward. And the reason is you want that some of the internet links or the website your employees are allowed to do or go out, right? And some basically should not be. For example, there are the gambling sites. There are so many sites which your company cannot allow you, right? And suppose that this guy in branch one is trying to access the poker.com, uh, which is the gambling website. Then what your company is saying, Mr. C, suppose this is Mr. C in the branch one, that please come to the data center first. Doesn't matter you are coming via MPLS or internet. Here, MPLS internet is just providing connectivity between the branch and the data center. Just come to the data center, and basically we have some rules configured here at exactly the data center, which will say that this traffic flow is not allowed. This is basically, I'm talking about the URL filtering, which can be done by the firewall. But firewall is not only for this, because you know that your website is running into your data center, and your data center is connected to internet, and there are so many users which are the legitimate user which are accessing your website and then ordering a sports good from you. That is fine, but you never know that internet also has so many guys which are only there so that they can disrupt your network, they can bring your website down, right? The malicious user, the hackers. And you do not want the access of these guys into your server. And that's why you put the firewall. If somebody is coming with unauthorized access from outside, he should be straight away denied from accessing your website. How firewalls do that? This is a separate, this is different altogether, right? But basically, you should understand the importance of this link, which is connecting your data center to the internet, because all of your branches, if they want to get into the, if they want to access the internet, then they should go first to data center, and then they are going to internet. You can argue with me, Mr. Vishnu, this is not the skill, this is not the model which we use in current world. You are right. With the invent of SD-WAN and the other technology, Now we can straight away go out from the campus because now we can provide the security right there into the campus and branches. But I'm talking general, right? If I'm talking general, then basically this link is very, very important because it is connecting your data center to internet. And if that is the case, if that is the case, who is going to design this, right? I can straight away see in this kind of topology right now, if this router gets failed, this router, right? Then basically your sports India is going to lose the connectivity to internet. Then you must be thinking why this internet is also there, right? But that is only to connect the branches to data center. This is not for the connectivity into the internet servers, right? If that is the case, then what is going to happen? If this link goes down or if this router goes down in the data center, then your sports India will definitely lose connectivity to the internet, and basically no user can order from your website, and this is definitely going to impact your revenues. It is as simple as that. So the whole sole idea is to make this link between the data center and internet as a robust link, and basically we should be thinking to design this link or basically the internet connectivity from your data center in a scalable, in a reliable manner, and definitely it should provide you the redundancy also, right? So if I talk about the internet edge, I'm talking about the internet edge of the data center. Or maybe if you have a campus which is big enough and you want to connect to the internet from the campus and you want a direct connectivity of the internet from the campus also, then you should be considering the campus design or the internet design in the campus, which is going to be the same, right? So we are working on a very small piece today, but it is going to, so it should be the start of the design, right? There are many, many designs for the data center, for the campus, right? But we are starting from the internet. Having said that, let's move to our first board. So what is happening, guys? Mr. Rahul, actually, who got a new job, he is also in this class and he has also understood what is the meaning of the internet edge now, right? And now what is happening? He is actually reading about few things, right? Over the internet also. So as you know that, so Mr. Rahul is still in its office. He is in starting 10-15 days. So he thought to read some more things because now he got an idea that he is going to be on a project which is basically on designing internet edge. So he is doing some research on the internet and he found an interesting article. And the article say, when do you need a public AS? And you all know what is the meaning of AS. AS is autonomous system number, right? So just like you have public IP addresses, right? And the private IP addresses, what is the difference, guys? The public IP address means it is routable over internet. If you have a public IP address, you can talk to internet using that IP address. It is as simple as that, right? And you can only talk to the internet if you have a public address. You can argue with me that, Mr. Vishnu, in our home, we get the IP address from the range 192.168. If I do a IP config on my Windows laptop, then I see that my address is 192.168, which is from a private address range, but still I can able to access the internet. Believe me, there are some devices which are converting your IP address into public IP address, or that you otherwise you would not have been able to access the internet. It is as simple as that, right? Public IP address is required because public IP address is routable over the internet. It is as simple as that, right? And if you send a packet to your service provider with the private internet address, it is going to straight away drop it. Okay, interesting. The second thing is you all know about public and private IP address, and that is why you know the NAT also. If you have private address, somebody is doing the network address translation for you. But if I talk about the autonomous system number, right? There are two types of AS number also. One is the private AS number, and the other one is the public AS number, right? So there is the range, I think, 60 500 512 to something, basically, which is the range of your private AS number, right? And these AS numbers are not understandable by the public routers. What is the meaning? The meaning is, suppose you have three autonomous systems numbers, right? This AS100 is of service provider 1, this is for service provider 2, maybe this one is AS200, right? And now you have an AS number which is 65520, and this 65520 is actually your autonomous system number, and it's a private. Believe me, just like you need to, if you want a public address range, you need to apply for it. And if you get it, then basically with that address range, you can talk over internet. But nowadays, getting the public address range is quite difficult. Similarly, in case of autonomous system, you can use from the private address range, but if you want to use a public address autonomous system, then you need to apply it. And here we are discussing only the fact that when do you need this public autonomous system number? Do you need in all cases or some specific cases? And let's talk about it. So if you see here, right here, on the left hand side of this complete picture, we have two or three autonomous system numbers. One is AS100 and the other one is 65520, which is part of the private range. And now you are advertising your subnet to the service provider 1, which is 163.10.10.0/24. When the subnet reaches here in this AS number, you all know about the fact that 163.10.10.0/24 is going to be learnt via BGP, and the autonomous system number comes with it is 65520. As I mentioned, this AS100 is going to, because service provider 1 definitely is going to connect it with other service provider, and that is why the complete internet is formed. All these service providers are connected, and which is giving you the feeling of the internet. It is as simple as that, right? Having said that, this service provider is going to advertise this route to service provider 2, and when this route reaches here, it will be the BGP learnt route 163.10.10.0/24, and what you see as the autonomous system number, yeah, AS path, it is going to be AS100, and then it is going to be 65520. We all know about it, right? That in BGP you send these attributes. If that is the case, then SP2 is going to see two autonomous system numbers. One is 100 and the other one is 65520. And here is my problem. The problem here is that SP2 does not understand 65520 autonomous system, and it can straight away discard this route if you send it with the private autonomous system number, which is your 65520. Similarly, the same exercise is going to be done by service provider 1. It is going to advertise the route here, right? And these service providers are not going to accept this route because it contains the AS number, which is the private one. It is as simple as that, right? Does it mean that you need the public AS for this kind of setup also, right? So service provider 1 is doing an interesting trick, right? Because service provider has a lot of subnets like this that belongs to its customer, which are directly connected to him and only him. So what he is doing, whenever he advertise a route which is coming from the private address range, which is coming from this, suppose this is customer number A, then he deliberately removes the private address range or private address autonomous system from its advertisement to its upstream service providers. If that is the case, the service provider 2 is going to get this route from 100, which is the public AS number, and that is why SPT is going to accept this route. It is as simple as that. So what can be done here, that the service provider is doing some extra bit of information. Sorry, it's doing some extra bit of work, and it's removing the destination IP. It is removing the uh, autonomous system from its updates. It is as simple as that, and that is why everything is working fine. But if that is the case, uh, can we use always this private autonomous system or AS everywhere, right? In this case, straightforward. This is straightforward that this customer number A, which is having 65520 AS number, is connected only with service provider 100. So basically, what we can do is we can just remove its AS number from its path, because we know that if the return traffic comes back to AS 100 knows that 65520 is connected to it, and because it is having the route towards 163.10.10.10, it can forward it. It is as simple as that. And why do we use AS number at the first place? We use AS number or the AS path for several reasons. And one of the most important reason of using AS path is to detect the loop and to avoid the loop or to remove the loop, right? How? You all know about it. So you must be thinking that can't it be resulting into the loop formation? It is not going to be. And the reason is, as I mentioned, that my customer A, and I can showcase you right here, that my customer A, which is having this AS number, right, 65520, is connected to only one service provider, like this, right? And now basically we are going to have so many service providers on the internet or autonomous system on the internet, right? Which are going to be connected like this, here, and maybe these are connected like this. You never know. But you know for the fact that if you know for the fact that this customer, maybe the customer A, is only connected to with this service provider, there is no question of loop, right? And the reason is, if we remove 65520 from the complete picture, then we know for the fact that service provider is connecting with this only over this link or maybe over the couple of links. But we all know for the fact that this autonomous system number is not connecting everywhere. So if we want to go out from this autonomous system or coming into this customer A network, we are always going to be coming from this service provider. And if service provider remove our autonomous system, it does not make it is not going to be create any loop, right? Suppose we are advertising update from here, and my update does not contain nice 65520, but it only contains the AS number of 100. And if the update goes here, and come back here, then definitely service provider autonomous system is seeing in the reverse path, and that is why this packet is going, or this update is going to be dropped. You do not need, in this specific case, that your 65520 value should go along with the update. It is as simple as that. But yes, the problem is different. If you connect this customer with another service provider, then it is going to be creating a problem in terms of loop. How? Let's see in the different diagram. If you see here on the right hand side of this diagram, right? Now what I've done is, now basically, and suppose the AS number is still 65520. I will be definitely letting you know what is the problem which is going to happen now. Now the same route, maybe x dot x dot x dot x is going to be advertised, or 0/24 is going to be advertised with 65520 AS path, right? And this ISP is going to advertise it to somebody else also, maybe service provider 1 or service provider 2, which is connected to this guy, or maybe 3, which is connected to this guy using another service provider, which is 4, like this. And maybe there is a loop, right, between these autonomous system, and there is going to be loops, right? Physical loop. Then try to understand what is going to happen. R3 advertising this route here. R4 is advertising x dot x dot x dot 0/24 here with this autonomous value. And you all know 65520 cannot travel over the public autonomous over the public internet. So what R1 is going to do? R1 is actually removing your 65520 in its updates. And if that is the case, then there is going to be problem, because this route can go from here to here, and it can be advertised from here to here, or any route basically can be advertised from here to here. If that is the case, then basically there could be a loop, there could be a potential loop in your network, right? And that is why you cannot have the private autonomous system number in this case, right? If you're connected to different service providers, and definitely those service providers are going to eliminate or remove your AS number, it is going to be for certain, right? And if that is the case, then basically there are chances of the loop. So if your autonomous system number is connected to different service providers, if you want to take the services of two different service providers, you need to apply for an autonomous system. In the left hand side, you do not need the public AS number. On the right hand side, you are going to need it. It is as simple as that, right? So what is happening here, guys? Where we are actually, Mr. Rahul got a new job, right? And he knows that within a week time or 2 weeks time, he is going to meet the customer to design its internet edge. He has a solid fundamental knowledge of the BGP along with the MPLS and OSPF. And now, because he is new, he is slightly in fear that it is going to be his first design project. So in the meantime, he is reading on the internet. But believe me, when he read this article on the internet, or when he saw certain video on the internet, he got to know all these things pretty easy, because he has a solid fundamental that why do he going to be needed, why he going to need the new autonomous system as a number if he is connected to two different service providers. Mr. Supreet, I can see that there is a question for you, but I will come to your question. Please let me explain the next board also, and then I can explain the question, right? So here you go. We are into the second board now, and Mr. Rahul has come across another interesting article, and believe me, you have gone through this, you know about this, but this is very, very important to take a look once again, right? Right now, we can see that there are three autonomous system numbers here. One is AS300, which is for maybe say customer A. Customer A is having the public IP address range, which is 163.10.10.0. He is also having the public autonomous system, right? But interestingly, how did customer A get the public address range? This one, right? So there are two ways basically you can get it. Apply to the central authority, I think IANA, which exactly gives you the IP addresses, right? But it is going to be very difficult. You need to justify so many things, that why do you need the public IP address at the end customer, right? So Mr. Customer A is using ISP2 address range. What is the meaning of using ISP2 address range? The meaning is straightforward. ISP2 is is pretty old in the market, right? And maybe 10, 20 years back, he has applied for a subnet. And luckily, at that point of time, that it was not that difficult process to get an IP address range. This service provider got a range which is 163.10.10. Sorry, it got a huge range like this, not 8, 16, suppose. So this service provider is having this public IP address range, and now the service provider can start allocating or subnetting this network, right? And give some of the subnetwork to its customer also. And try to understand that this is a /16. It means that there are 2 to the power 16 host and 2 to the power 16 network, right? If we do not do anything, then basically the host portion is 2 to the power 16. It is huge, right? So now customer B, sorry, the ISP2, what it is doing, it is allocating a /24 range because it knows that if customer A wants to talk to internet and he has some servers which should be on internet, then it means that these servers should have the IP address, right? The public IP address, and that is why he is getting those IP addresses from service provider 2, which is this one, right? This is straightforward. Then what is the problem? The problem is what is going to happen if this guy R4 advertise this range from R4 to R2? It is going to advertise 163.10.10.0/24 here in the BGP, and suppose we are running BGP over this link, and here also it is going to advertise the BGP route, which is 163.10.10.0/24. And you must be thinking that what is wrong with that? This is perfectly fine, right? You all should understand that basically these ASs are connected to some further ASs also, right? Like this, or maybe the connectivity could be anything else also, right? Maybe like this. If that is the case, this service provider 2 is actually an efficient service provider. What it is doing, it is not advertising all the /24s. What is the meaning? The meaning is just like customer A, service provider can have many customers, right? Which have been asking him for the public IP address range, and he is allocating /24 to everybody, right? Maybe he has more than 100, 200 networks which he has allocated to the customer, or maybe 1,000 of those on this network, right? After subnetting this range. So you all know for the fact that if I can take an example x.x.x.0/24, it contains 2/25, right? Right? Or it contains 4/26. If you do not get it, what I'm talking about, please do my subnetting section of the routing fundamentals, right? So this address range can be subdivided with 4 different subnets if we use /26, or maybe 8 if we use /27, or maybe 16 if we use /28. It is as simple as that. But suppose if I have 16 network which are basically /28, then if I want to advertise it from a router, I know that after this router there are basically 16 subnets. What I can do is I can advertise only one network, which is x.x.x.0/24, because this network contains everything whatever I have after this router. So it is advisable to advertise the summary, and this address is known as summary for all these subnetworks, right? What is the advantage? The advantage is instead of sending the 16 routes to the remote router, you are just sending one route. It is going to make internet routing table small. It is as simple as that. And that is why Mr. ISP2 is doing, he is advertising only the /16, right? 163.10.10 sorry, 163.10.0.0, which is the summary route for all of his customer, because it contains whatever the subnet he has. And the advantage is that the internet routing table, the meaning that this router, or any other router, whatever is going to receive this slash 16 route, it is actually receiving it as a slash 16 and not maybe thousand of routes with smaller subnets. It is as simple as that. And ISP2 is summarizing it. This is perfect. No worries, right? But let's try to think that for this customer A, ISP2 is the primary ISP, which is right here, right? And suppose it has taken a 1 Gbps connection from the ISP2 for the internet connectivity. And this guy, ISP1, is just the backup, and he has taken only 300 Mbps connectivity from the ISP1 right here. What is going to happen? Doesn't matter that who is a 1 Gbps, who is 300 Mbps. The network is built like this. This is the primary network, and if this fails, then basically this is the secondary network, right? But what is the problem happening right now? That we are also advertising 163.10.10.0/24 to service provider 1, and this service provider 1 does not have the summary route, right? It doesn't has this range of IP address. Maybe the service provider is different and he got the range from something like say 200.10.0.0. He is also having a range for his customer. He has also applied and he got the slash 16, but this is a totally different range. Of course, these two service providers are different. They have gone to the uh, uh, internet, the authority which assigns the IP address at the different time, and they got the different subnets. They should be, right? If that is the case, then your ISP1 is going to send this summary, right? 200.10 for all of his customers, right? And although you are his customer, but you are not getting the IP address range from this service provider, you have purchased the IP address range from this service provider, which is ISP2. It is as simple as that. If that is the case, then ISP1 has to advertise your subnet with only slash 24, right? 163.10.10.0 slash 24 is advertised by this service provider. If this is the case, then basically you are making internet tables big, right? But it should go this way. Otherwise, nobody can able to reach you from this service provider, right? This link cannot become your secondary link. It is straightforward, right? But once you build this setup, there is an interesting thing going on. The interesting thing which is going on is that all of your traffic is coming from here only. Interesting. And no traffic, if you say this is path number 1, and no traffic, and if I show the path number 2 with the blue color, no traffic is coming from the internet into your autonomous system on path number 2, which is the blue color path. The path number 1 is the traffic path is the red color path, which is coming via AS100. It means that you have been using your secondary link for most of the traffic, and nothing is coming inside from this 1 Gbps connection, which you do not want. And you should understand the reason behind it, right? Because to any router on the internet, suppose this was that router, it is getting two route. One is via AS200, which is having the or the subnet mask value is 16, and one it is getting via AS100. Any router on the internet, the route is going to be same, but the subnet mask is going to be different. So from AS100 it's going to get the slash 24, and you know that the longest prefix match, or the route which is having, if in case of the same 4 octet route, we are going to see the different subnet mask. These two routes are going to be totally different route. This is basically /16, this is /24. If that is the case, the longest match routing is going to happen on all the internet edges, sorry, on all the internet routers. If that is the case, the /24 is always going to be preferred by the internet routers. And if that is the case, every internet router is going to send the traffic towards you as a customer A from AS100. And if that is the case, then this link is going to be your heavily utilized link, which you do not want, right? These type of addresses are your provider dependent address. Which type of addresses? The addresses which you are talking about 163.10.10.0/24, which is given by the service provider ISP2, and that is why this is the provider dependent IP address, right? How to avoid such kind of situation? Then you need to talk to Mr. ISP2 also, that Mr. ISP, I am facing this issue. And if that is the case, ISP2 has to announce the /24 range, right, from itself towards everybody. So these are the two things which Mr. Rahul has been searching on internet, looking into it, that what should be we should see while designing an internet edge. So he got something, and believe me, we have learned address summarization. So reading this article is going to be very easy for you if you come across, and that is why I mentioned that if the learning journey of this OSPF-BGP-MPLS is 100-kilometer long, I can walk with you for the initial 50 to 20 or 25 kilometers. And the remaining journey, maybe you can do when you do your project. But you are going to be so solid that if you want to go 100 kilometers inside this, you can straight away go. And that journey is going to be simple because the base is really, really strong for you. Having said that, Mr. Rahul is all set for his first project and he is going on the customer site, right? But before that, I could see that there was a question from Mr. Supreet. Mr. Supreet, please do ask your question.
Hey Vishnu, thanks. So basically for the public and the private AS, so let's say for example, when we are single home, we need a private AS, and we are multi-home, we need a public AS, right?
Yeah, basically in the single home network means if you have only one service provider connected to you, you do not need a public a public AS number. Okay, because it is.
And when,
Uh-huh.
yeah, and the second question would be, so when we apply for a public AS, do we need to apply for a public IP as well, or it depends upon your design?
It depends on the design, but yes, means generally it is seen that if you have a public AS, then you should have this public IP address range. And believe me, you should be having this public IP address range. Either it is dependent on the provider, means provider dependent, or you have stayed away, because no enterprise can work without a public IP address, right? You can say the NAT is there, but NAT actually also convert your entire private IP address range into the public. So you need a public. Generally, the enterprises gets the public IP address range from, if it's upstream provider, or maybe this enterprise is bigger enough to go to the directly towards the authority and apply the public address range from there. Okay, Supreet?
Yep, got it. Thank you.
Perfect. So now let's talk about, so here's the thing. Mr. Rahul is all set now, and his company, I'm not sure what is the company name, but Mr. Rahul is informed by his company or his superior or his manager that there is a new project come from maybe Sports India, right? And they want to revamp their internet edge. And that is why basically what we have done is you should go on site, and the customer is calling you on site for at least 2 days workshop. The meaning of workshop is so that this guy, Rahul, can interact with the customer network engineer team. They can sit together and brainstorm on what they do want, right? And maybe on those 2 days, maybe Mr. Supreet can talk about the high level design too. Generally, it doesn't happen that in the starting 2 days workshop, you can create the entire design. But yes, this is the starting point that how you are going to uh, this is the starting point where you collect the customer requirement and start thinking about the high level design, right? So here is the thing. What is happening? Mr. When Mr. Prashant, sorry, not Mr. Prashant, Mr. Rahul here went to on site to this customer, which is a Sports India. He's meeting with uh, customer network engineering team, right? And now Mr. Rahul is saying, what is the problem, right? If you want to revamp or if you want to change your existing internet design, then you must be facing some issue with the current design, right? Otherwise, why would you change this thing? So the network engineering team of Sports India, what they are saying is that absolutely yes. Right now, what we have is, so they started explaining their network, right? So the network engineering team of customer, maybe the Sports India right here, or the customer A, we can say Sports India or customer A, the same thing. They are saying that we have private AS number. Then Mr. Raul is saying, okay, that is perfectly fine. Then they say we have one public address range. Then Mr. Raul is saying this is again good, no problems with respect to it, right? And then customers say this is the provider independent address. And now here Mr. Rahul get confused that what is provider independent, right? He has came across the term provider dependent where provider actually giving the IP address to him, and he knows for the fact that yes, provider independent means the IP address which doesn't depend on your provider, right? Suppose this is the ISP1, but he straight away asked the customer, so if you have any doubt, right, and if you think the doubt should be asked, right? Maybe sometimes when you go onto the customer site, customer is talking into its own language, whatever they use at their network. Some terms are basically created by them. Some terms are pretty standard. This term provider independent is quite standard though, but it quite be the case that you do not understand it. You do not have came across the term, and that is perfectly fine, my friends, right? If you are on a customer side, right? If you do not get it, please do ask. Otherwise, it is going to be problem. So the number one thing, right, of the design should be that you understand the customer problem. If you cannot understand it, or if you don't think that is important, then how you are going to solve the problem, right? Customer is actually making you understand what its problem, right? So whatever comes to you, the new term or something, there is no harm in asking. And that is why Mr. Raul is asking, what is the provider independent? And the customer is pretty happy to explain him that provider independent means that as an organization, we straight away go to the Internet Authority, which is actually assigning us the IP address, and we straight away applied for the IP address range, the public IP address range, and we got it, right? We got a /24 from the Internet Authority. It is as simple as that. And why I am saying it is not depending on the provider, because I haven't taken it from the provider. I have taken it directly from the authority. So it doesn't matter how many service provider I'm going to connect to. I do not get the problem which I showcased you on the previous board. Both the service provider has to advertise this. It is as simple as that. Having said that, this is good. So these are the two information which is given by the network engineer. And now Mr. Prashant is saying that I can see that you have two links towards the service provider one, which is AS100, link number one, link number two. It means that you have a link redundancy, and that is what that is what network engineering team is saying. That in current network was working pretty fine, Mr. Rahul, but last month was actually quite disappointing. Disappointing in terms of business also, and our CEO has clear indication that we need to change this because if the internet goes down, then basically we can see there are so many problems with respect to revenues also. This is Sports India. The revenue of Sports India is totally dependent on the internet connectivity because they are running this web server and various applications, right? And if this site is not up and running all the time, it is not on the internet, then basically they are losing the revenue. Mr. CEO is thinking that let's close the data center and move it to the cloud because cloud has almost 99.9% uprate. Why we are running this data center at the first place if we cannot provide the internet connectivity, right? And the problem, then Mr. Raul was thinking that what is the problem right now happening, right? Or that happened last month. So they said that this complete service provider was down, right? It means that they were not able to reach to the internet. And I'm not saying that internet is directly connected to this service provider, but yes, because this service provider is connected to other autonomous system, and that is what the definition of internet is. If that is the case, basically this guy is not able to reach different autonomous system number because this one is completely down. What was the reason? They do not know, right? This happened 1 month back. And now recently, 2 weeks back, there was some problem and it happened. The problem persists for 2 or 3 hours. And for these 2 or 3 hours, our business was down. It is as simple as that, right? Then the second, when this business comes up and the service provider says, sorry, there was little bit misconfiguration at my end, and the service provider is good enough. They're saying that whatever the loss happened to you, I can give 20 to 30% to it. But yes, this is not about only the loss. This is about the reputation also, right? If the customers are not able to order, if the customers are not able to order, guys, right, there is going to be a problem. And there was a second issue, second problem which happened, right, 2 weeks back, that this internet router was down, and you can see this is the single point of failure. So there are two single point of failure. One is the service provider itself. If this goes down, then there is no internet connectivity. And the second thing is, if the router itself goes down, then this is again the single point of failure. It is as simple as that, right? So Mr. Rahul is getting all the problem from the customer, right? And now he is into the solution mode. What is the meaning of solution mode? The solution mode is he is straight away suggesting few things to the customer. Mr. Shafayat, I could see that you have a hand raise. I will come to you, right? Let me explain two more boards and then we can discuss about it, about your questions, right? So if I may ask, then what is the customer requirement here, right? What should Mr. Rahul got from the customer? The requirement is straightforward, right? The requirement is just this, that the internet is a mission critical service. They cannot deal that if internet goes down, that what is going to happen. Their CEO is pretty particular about it, right? He do not want that this internet should go down. So Mr. Rahul understood this thing, that there is only one requirement, that the internet is a mission critical service. And now what Mr. Rahul is suggesting, he is suggesting to the customer that you should have at least two providers. Customer is saying, yes, I agree with you, Mr. Rahul, because as we can see that we cannot always dependent on this single service provider, which is might be ISP1, right? If we dependent on this and if this ISP goes down, then it's a problem, right? So we understand that what you want to say. Then the second thing which is going to happening here is Mr. Rahul read that article, right, along with his fundamental knowledge, that if I am suggesting two providers to this customer, then definitely we should be applying for a public AS also. And that is why he is saying that it is the high time that you apply for public autonomous system. Because if we are going to have two service providers, and if we have only private AS, it is not going to work. And interestingly, customer didn't know about it, and that's how Mr. Rahul whiteboard the complete scenario, just what we have discussed, right? The customer got very impressed that this is great, right? Of course, you will be applying for the public autonomous system. And by the way, guys, getting IP address range is little bit difficult nowadays, but getting an AS number is comparatively easy. You just need to justify that yes, you are using two service providers, and it could cause a problem on the internet if I use 65520, which is my private address number, right? AS number. So that is the whole sole reason why Mr. Rahul is suggesting that please have public AS. The third thing he is saying that there should be three connections now. Why three connections? Customer just asked that. He said that whatever the connection you have right now, this might be the 1 Gbps, this is the 300 Mbps, which is the secondary link of yours. Whatever you have, you should have these two. That is perfectly fine. But I am talking about a connection, another connection from the service provider 3, service provider 2, or ISP2, right? That is why I'm saying three connections. Then he's saying, why three? Why can't I can just remove this one and I can have only two connections. One is primary to this circuit, one is primary to other circuit. And Mr. Rahul is saying, do not worry about it. I will explain you this thing. But right now, my suggestion is that it is going to add more redundancy if we have three connections here. This is interesting. Mr. Rahul is also saying that why to make this single point of failure? Why can we have another router and connect the other link to this wire? Interesting. Definitely we can do that, right? And now he is saying that do not worry about the fact that your primary link, which is 1 Gbps link, because you are spending some amount of money here, the most amount of money on this 1 gigabits per second link, we will be using this as a primary circuit. So these are the suggestions. These are not the design, but these are the preliminary suggestions which are suggested by Rahul. And now Mr. Rahul is saying, give me just a daytime, right? And I will come up with a little bit of diagram of whatever whatever I suggested to you. So now Mr. Rahul is in his hotel and he is contemplating on the design. He's thinking aloud that what it should look like. So he has come across this picture. He has designed this picture, and he's saying that this is not the high level design, but I would like to present this to you, that what I am thinking, right? So whatever he just said yesterday, he is repeating the thing that we are going to have two service provider. This one you have already Airtel, and this is the data, which is the second service provider. And I'm not changing your any link. This is going to be my 1 Gbps link. This should be the primary one. This one is the 300 Mbps, which is the secondary link, right? And now I just move this link from the router number 1 to router number 2, and Mr. Rahul has gone through their network topology. He could see that there is another router which could be utilized for the connectivity of this third link. So this is link number one. Say I'm writing this link numbers with the red pen. This is the link number one, which is the primary link. This is the link number two, which is the secondary link with the Airtel. And this is the third link, which is the Tata link of 300 Mbps, right? And Mr. Rahul is saying that all the links are in different net routers because this customer is having that independent routers. If they do not, then probably to avoid the single point of failure, we should not be having all the three links of R1 itself. Yeah, but what we can do is we can have this link. You can utilize R2 also to connect directly to data, right? And but it depends on what your customer has. So Mr. Rahul was saying his topology, he find this router can be utilized for another link, another internet link to the Tata, and that is why he has the three different routers, and that is how it is very unlikely that all of these three routers are going to be die at the same time. It is very unlikely that Airtel and Tata's both network goes down at the same time. It happens, but it's very rare. It is as simple as that. So Mr. Rahul has explaining all this thing to the customer that we should be having this, right? And when customers network engineering team is seeing this diagram, now they are saying we have some more requirements, right? When you present, and it happens, right? When you present something, customer says, okay, I want this, but I want something more. And now, previously, there was only one requirement. The customer was saying, internet is our utmost priority. It is a mission critical thing. Can you make a network for it? And now customer is saying, okay, that was the thing. That was the thing for sure. That internet is a mission critical for us. But now we are saying that we have some more requirements. And by the way, guys, if you do not see whatever I have written here, this is not for you. This is for me, right? Whatever is written in the red color in the small fonts, so that I do not forget anything, right? So the customer is saying, now I have some more requirement. The requirement number one is that the 1 Gbps link where I am paying so much, the link number one, right here, it should be no doubt about it that it should be my primary link. Most of the traffic should go over it because this is a 1 Gbps connection. I have taken a lot of SLAs, service level agreements for this. And by the way, guys, if I write Gbps, this B is small. It means gigabits per second, right? But when we have the hard disk or when we try to measure the data in our hard disk or something storage, this is Gbps, gigabyte per seconds, right? If we measure that speed, right? So, or the if we see this, most of the time we see that it's a big B when we talk about the storage, but when we talk about speed over the internet, it is Gbps, the small b, right? Just take this consideration also. It is not the gigabyte per second. Of course, then this unit is smaller as compared to this one. Now, the customer is saying that the primary link should be the link number one. This is my first requirement. The second requirement is that R3's link, whatever the link you are specifying here, link number three should be used only for Tata. What is the meaning? The meaning is that Tata is going to have giving some services here to me, right? Maybe these are the services. And Tata has its own customers also, right? Where I want to reach out to also, right? So basically for Tata's local networks and Tata's partners or the customers of the Tata, if that is the case, if I want to reach to them, then basically I should correctly go to Tata and then go to their customers, right? It should not be like this, that if I want to go to the Tata's network, I should be going first to the Airtel and then maybe over the internet I am coming back. This internet, guys, is nothing but various AS number, and maybe your Airtel and Tata is also connected. So like this, I am coming like this, right? Because Tata is one hop away from me, I should go directly to reach its network and its customer's network. So this is another requirement from the customer, that Tata's local network plus its customer should be reachable over link number 3. It is as simple as that. Interesting, right? Now let's talk about, now the customer is saying these are my starting two requirements, and now what I want to do is I want to have some failure requirements. If some link fail, then how the traffic should behave, I will talk about it now, right? And now Mr. Rahul is thinking that, okay, whatever I inform the customer, now the customer is also thinking aloud. This was your link number 1, this was your link number 2, this was your link number 3. The first requirement was that your link number 1 or R1's link should be the primary, right? The second requirement was that the Tata's local network plus its subscribers or the customers can go over link number 3, right? For the traffic, it should not go to the Airtel and to the internet, right? The third thing is the failure scenario, which we are going to discuss right here. If 1 gig links fail, if this link number 1 gets fail, then basically the traffic should go over the remaining 2 links. This link should come into picture. This link should come into picture, and you should be fairly load balancing between them. What is the meaning of fairly load balance, right? In BGP, you cannot always say that the traffic, if you have two interfaces, then over one interface, the traffic should go 105 Mbps and the other also 105 Mbps. It should not be the case like this, right? BGP cannot handle such situations. But yes, the fairly means if you can, then 100 Mbps is going like over this interface and maybe 110 going over this interface. This is fine. This is fair. But it should not be the case that only 10 Mbps or the going over this interface and the remaining more than 120 or then what we can say the 200 Mbps is going over this interface. This should not be the case, right? Then you are not evenly load balancing. So the customer is saying that if the 1 Gbps link goes down, right, then the traffic should be load balanced between 3 and 2 link. This is the requirement number 3 from the customer, right? And now there is another requirement from the customer, which is requirement 4, and he's saying that if now for this situation or the number 4, basically 1 Gbps link is up and running. Now he's saying what is going to happen if this link goes down, this one, the data link goes down, then also you should be able to reach Tata's customers and Tata's local network using the primary link by coming to Airtel, maybe from via internet, or if these are directly connected, then like this, right? It means that if 300 link goes down, if the 300 Mbps link on R3 goes down, then basically you should be having the alternate path via 1 Gbps link. This is what customer wanted. This is what customer is expecting. It is as simple as that. So if the fourth requirement is if R3 link is down, right, you should be able to reach via 1 Gbps link on R1. It is as simple as that. Okay. So here actually I take a pause in the Hindi class because definitely we got the requirement. Mr. Rahul got the requirement and now he is brainstorming on those requirements. I want to do that brainstorming with you guys, how we are going to create this network, right? And we will be starting that tomorrow morning at the same time, but now I can see that there is Mr. Naveen and his question.
Yeah.
Mr. Naveen, please ask your question. Yeah.
Thank you, Vishnu. So here we are just discussing about that traditional routing, like wherein the primary and secondary concept. So wherein generally when we set that particular link to the service provider
Hmm,
as a primary,
hmm.
so our 100% traffic will go over the primary link, and that fails, the traffic will fall back to secondary links. But in current SD-WAN technology, normally if you see one link, we will be having MPLS and another one is internet transports, that both will be in active model. Then how does this works?
Yeah. So
The
basically,
primary and
yeah. So
secondary
basically,
concept.
that is why there is a requirement of new technology, right? So that you can
Yeah.
efficiently do this load balancing. Basically, now you are, if you are going to have two different, and we are through SD-WAN, right? Through SD-WAN, we are actually not dealing with the internet edge, right? So that is what the difference is,
Okay.
right? Just try to think, right? We have this data center, right? And we have different
Right.
branches. And you
Okay.
all know that there could be a lot of traffic. We are having this MPLS and we are having this internet, right? So basically, there is a internet traffic right here. I am talking about this one, right? To draw, to design this one. But what you are talking about is right now that how this branch is able to communicate to DC or other branches via on this medium, whatever we have, right? Although this is again the
Okay.
WAN connectivity, but your question is right, right? And that is why we have the SD-WAN. And I'm not sure whether you have gone through my SD-WAN series or not, but there is a great explanation that we have application aware routing there, right? We can do the for sure that some of the traffic, right? If this link is up and this link is basically performing with respect to my SLAs. I can forward it all the traffic towards it. But if I see that there is a problem with respect to this link happening, we can move the traffic here, and you should not be able to do once this goes down or something happen. If my SLAs are not meeting, I can move it towards this. And the active is quite possible here also with the BGP. Suppose you have two links here and here, right? And you have these two
Okay.
routers here. And if you want to utilize both the links, just try to think that we are utilizing. It is not like the fact that it's a pure primary secondary. Some traffic is going on
Mm.
this 1 Gbps. I'm pretty sure that I agree with you that we are not utilizing this 300 Mbps link. This is the secondary one. But we are utilizing this link of data, right? So it is not
Correct.
purely the active standby case. It is the active case. But try to think that we have spent 1 Gbps. We have spent a lot of money over this link of 1 Gbps because customer is saying that we have taken a 1 Gbps link and we are providing a huge money to this service provider because we have SLAs to it that this link is always going to provide me the 1 Gbps, although no service provider is going to give you this SLAs over the internet. But yes, suppose it is the case, then why to send this? Why to send everything over the 3 Mbps link, which is not SLA provided, right? SLA means that service
Okay.
level agreement that the service provider is giving you the guarantee that I can give you 1 Gbps link, send the traffic, and it is my responsibility. And if something goes wrong with respect to this link, I can pay you also, right? So if that is the
Oh,
case that I am providing, I am getting out everything from this primary link. But yes, I have this data link so that I can go over this link too. And I'm doing that. So right now, link
okay.
number one and link number three is active. But yes, I'm sending most of the traffic to 1 Gbps link. Okay.
Okay. Okay. So the sending most of the traffic on 1 Gbps is you are basically um, doing a cost marking, or you are forcing the traffic to send the through 1
How
Gbps.
we are going to do that, that is the brainstorming what we want to do in the tomorrow's class. Okay.
Okay.
How
Okay.
portion, I'm not saying that I'm leaving you right here that a customer is telling the requirement and I left. No, no, no. Mr. Rahul is going to do the brainstorm along with you guys. You need to give the inputs to him. Tomorrow's class is going to be definitely very, very interesting. The starting half an hour on this topic because we will be formulating the solution for this. Okay.
Okay. Okay, Vishnu. Thank you.
Now, Mr. Shafayat ji, please do ask your question now. Mr. Shafayat ji, I am not able to hear your voice. Anybody else can hear Mr. Shafayat? No? Yes? Okay. Anybody can hear anything from Mr. Shafayat?
No.
Okay. Okay.
Now, are you hearing?
But yeah, Shafayat ji, but I can hear a lot of noise from behind. There is a lot of noise, Shafayat ji. It would be great if we can be on mute, please. Yeah.
Sir, are you hearing now?
Yeah, but I can hear you, but there is a lot of noise.
Sorry, sir. Sir, actually, my question was if my customer requirement is transferring 1G link to another IP's 1G link, but the fact is,
Shafayat ji, can you please ask your question tomorrow because there is a lot of disturbance
okay,
here,
okay.
right?
Okay, sir.
Okay, perfect. Please be on mute. Please be on mute. Yeah, thank you so much. I couldn't hear much, but he was asking something that if we can shift the traffic. So please ask your question tomorrow because we are going to discuss this in the first half. Having said that, enjoy your day, guys. See you tomorrow at the same time. Have a nice day ahead. Bye for now.
Yeah, thank you, Vishnu. Thanks, everyone.